Hi, this is Mrs. Basin. Today we're going to talk about conversions. So if you remember from Chem 1, the mole is sometimes called the chemist's dozen. So because particles that we're talking about are so small, the mole is a unit that they came up with to make it a little bit easier to deal with. So 1 mole equals 6.02 times 10 to the 23rd particles, and if you remember, that's known as Avogadro's number. So if you're looking at some comparisons here, you can see that 1 mole is always 6.02 times 10 to the 23rd atoms or particles of a substance, but 1 mole is also equal to what we call the molar mass of a substance. So if it's an element, 1 mole is equal to that number off the periodic table. So like aluminum is 26.98, carbon 12.01, and helium 4.003. It can also be equal to the molar mass of a compound. So if you had a compound like CH4, 1 mole would be equal to 1C plus 4 H's added up. So this is the conversion chart that we used in Honors Chem. So let's just kind of go through and remind ourselves on what the conversions are. So if you're going from atoms or molecules to moles, you remember that 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. And that just depends on what it is. So it's 6.02 times 10 to the 23rd. If you're dealing with atoms of things, you use the unit atoms. If it's molecules, you use molecules. If you're going from moles to grams, then we use 1 mole equals the molar mass in grams from the periodic table. So you can't go directly from atoms or molecules to grams. You have to go through moles first. Okay, so let's do a couple example problems here. So it says calculate the number of copper atoms in 2.54 moles of copper. So you always are going to start with that number that's given in the problem. So 2.45 moles of Cu. And we want to go from moles to atoms. So just to kind of remind ourselves here, you can go from atoms to moles to grams. So for this one, we're just going from moles to atoms, so it's only going to be a one-step conversion here. So 2.45 moles of copper, there's 6.02 times 10 to the 23rd atoms in 1 mole. And then you remember you multiply across, you divide top to bottom. So this would equal 1.47 times 10 to the 24 atoms of copper. And then when you're doing sig figs for this, you always go back to this original number that you write down. Remember, the conversions don't count for sig figs, so if this has 3 sig figs, then my answer is going to have 3 sig figs as well. Okay, the next one we're going to look at is how many copper atoms are in a copper penny with a mass of 3.10 grams, and assume it's composed of pure copper. So again, we can go from atoms to moles to grams. So in this case, we're given grams and we want to go to atoms. So we have to go the opposite way. So we have 3.10 grams of Cu. So to get from grams to moles, we're going to use the molar mass of copper. And just like in all our conversions, the thing you want to cancel out has to go on the bottom. So 1 mole of copper would go on the top, and then 63.55 grams would go on the bottom. Now we want to go from moles to atoms. So 1 mole goes on the bottom, and that's where we use our 6.02 times 10 to the 23rd. So multiply across, divide top to bottom, and we get 2.94 times 10 to the 22nd atoms. Again, 3 sig figs in the original number, 3 sig figs in our answer. All right, our last one says what mass of iron in grams is in a paperclip if a paperclip contains 1.20 times 10 to the 22nd atoms of Fe. Okay, this one we're starting with atoms. We're going all the way to grams. So the first thing we have to do is get rid of atoms. So I know that 1 mole of Fe equals 6.02 times 10 to the 23rd atoms. And then I know that 55.85 grams of Fe equals 1 mole. And this number comes from the periodic table. That's the molar mass of iron. So I would have 1.11 grams of Fe. Okay, now the only new thing that you'll see, and I'm just going to write a couple things on the bottom of this. I mean, you could add this to the bottom of your page if you wanted to, is that you might be asked to go from atoms of something within a compound to a molecule, and then from molecules to grams or molecules to moles. So if you had something like C6H12O6, it could ask for how many atoms of oxygen there are in this whole molecule. So this whole thing would be a molecule. But there are atoms within that molecule. So you can actually use, and I'm going to cross that out because we're not using that, you could actually use the atoms within per one molecule. So conversions you could use for this is you could say there are 6 carbon atoms per one molecule of C6H12O6. You could say there are 12 H atoms per one molecule of C6H12O6. You could say there's 6 carbon atoms per 6 oxygen atoms, depending on what it is that you're trying to convert. So these would all be separate conversions you could use depending on what it's asking for. So the practice that you're going to do in a little bit here it kind of takes what we've done a step further. So it might ask you how many atoms are in a molecule of something, or it might say if you have so many grams of a molecule, how many atoms of one of those, how many atoms are within that many grams. So if that gets confusing as you're working, look at the answers that are on the front table and look at the examples and kind of follow that through. So if you just remember that you can use atoms within this whole molecule. So that whole thing together is a molecule, but you can use the atoms within it as a conversion as well. So keep that in mind. But then once you're in molecules, you still have to go from molecules to moles to grams. So if you're starting out with like molecules or atoms and you're asked to find grams, don't forget you still have to go through the moles just like we've done with all the others. Okay, so work on what I left there, work with each other, work with partners, work through it together, and then just any questions you have we'll go over tomorrow when I come back. All right, see you guys tomorrow.